Hello everyone. In this video we're going to be solving an interesting differential equation. We have y double prime equals 1 over the square root of y, and we're going to be looking for a function y that satisfies this equation. Now what makes this equation pretty interesting is the fact that we have the second derivative on the left hand side as opposed to the first derivative. Now what would happen if we had the first derivative? Let's think about that case first, right? So suppose we had y prime instead of y double prime. Now, in this case, we could definitely write y prime as dy over dx, and then leave the 1 over root y alone, and then kind of separate the variables, multiply, cross multiply, I guess you can say that. Square root of y dy is equal to dx. And then you could definitely integrate both sides, right, with respect to the variable on each side. And then from here, this would become y to the power 1/2. By using the power rule, you can basically say that, okay, this is going to be y to the power 3/2 divided by 3/2, which is 2/3. And then that is equal to x plus constant on the right-hand side. And of course, to make things a little easier, you can definitely raise both sides to the second power, or just leave it like this, 2/3. This means the square root of y cubed equals x plus c, and you can put it in any form that you want. So that will be fairly easy to do because it will be a separable differential equation, which is the easiest case to solve, okay? Now, but we don't have that luxury. We have the second derivative. That's what makes this problem super duper interesting. So let's go ahead and see what happens in that case, right? You don't really have that option because if you wrote this as d squared y over dx squared, and this is going to be 1 over root y, how are you going to handle something like this, right? That's going to be, I think, impossible. So instead, we're going to do a neat trick here, which is multiplying both sides by y prime. Guess what? When you do, you're going to have y prime on the right-hand side, which is a good thing because along with the square root of y, we can kind of turn it into something differentiable or anti-differentiable. But on the left-hand side, we also get something cool. Let me show you. Y double prime times y prime equals y prime times 1 over square root of y. Now, first of all, think about the right-hand side. What is this the derivative of, right? Well, if you just had 1 over square root of x, hopefully you can turn it into something like this. X to the power negative 1/2, and then this is the derivative of, you just need to integrate it, right? So we're going to go ahead and add 1 to the power. It's going to be x to the power 1/2 divided by 1/2, which would mean 2 times the square root of x. So if you integrate this, you get 2 times the square root of x. You integrate this, you should be getting 2 times the square root of y, but y is a function of x. Guess what? From chain rule, this actually can be written as 2 times the square root of y, or the derivative of that, right? Why? Because when you differentiate square root of y, you get 1 over 2 times the square root of y. When you multiply by 2, you get the same thing. Make sense? So the right-hand side is actually a derivative of something, which is great. What about the left-hand side? Okay, that requires some work to be done. So here's what we're going to do. We're going to think about like y prime and y, right? Y double prime and y prime, I'm sorry. So let's go ahead and look at it this way. We have this product. So if you call this u, this kind of becomes u prime times u. When do we get u prime times u? Again, by chain rule, if you think about it, and we used substitution here. This basically means, okay, u is the derivative of what? Think about it. In other words, you're integrating u with respect to u. That would be u squared, but its derivative is 2u, if it's your birthday, by the way. Happy birthday to you. And then, of course, it's half of that because you want the 2 to cancel out, right? So in other words, if you differentiate this, you'll get exactly u prime times u. Why? Because u is a function of x, because y is a function of x. So by chain rule, when you differentiate something like this, you would get 2u over 2 multiplied by u prime, because you always have to differentiate the inside. Remember how the chain rule works. And the 2's cancel out, and boom, we get the exact same expression. So this is what we have then. U squared divided by 2, the derivative of that on the left-hand side. And on the right-hand side, you have the derivative of 2 root y. Isn't that cool? Well, it's going to get better. Now, what is u though, right? Or can we think about it this way? Can we integrate both sides now? Yes, because we kind of have like two functions like f prime equals g prime. And this basically means f and g only differ by a constant because its derivatives are equal. And you know, as you know, the derivative of a constant is 0. So we can safely say that from here, u squared divided by 2 is equal to 2 times the square root of u, square root of y, plus c. Awesome, that's amazing, isn't it? Now we can go ahead and multiply both sides by 2, and that's going to give us 4 times the square root of y plus 2c. By the way, 2c is just a dumb constant. You can replace it with c1, or you can just call this c1, and 2c1 you can replace with c, okay? You can do so many different things. You have the ability to do so. So let's go ahead and call this c. Now we're going to get the following equation. But wait a minute. Is this a differential equation? Yes, but you have to back substitute. What is u? Who are you, right? What is u? What are you? U is y prime. So now you need to replace this with y prime. So y prime squared is equal to 4 square root of y plus c. This means there are two solutions. When you square both sides, because this is a nonlinear differential equation, I don't think you want to solve it, and it's an easier case, so you can easily square root both sides. There's going to be two solutions with the plus minus sign. I'm going to go with the first one, if you don't mind, because the second one is super duper similar. So let's just go ahead and square root and go with the positive square root, which is this one, okay? Now notice that this actually turned into something super duper nice because we don't even have an x in the equation, which means this is separable. That's awesome, right? Now let's go ahead and replace y prime with dy over dx. I didn't say dx wouldn't be in the equation. Of course, it has to be there, right? So we can separate them. But guess what? Now we can put the y's on the same side, right? And is that awesome? Well, kind of, because this is not an easy thing to integrate, right? Because at this point, what are we supposed to do? Integrate both sides with the big elongated s sign, which means sum, right? Okay. Now, what are we going to do? We're going to integrate this, and to be able to integrate this, there's a couple different ways to go about it. One option is you can call this u or something like it, but we already used u, maybe we should use t. Or you can just go ahead and actually call the whole thing t, which kind of makes more sense. You want to include the square root? That's also an option. I haven't tried it, but I think this will work nice. Let's go ahead and give it a try. So here's the idea. By setting that whole thing inside the radical equal to t, right, we are able to change the variable and find dy. But to find dy from here, we kind of need to isolate y. So let's go ahead and subtract c. And then there's a couple different ways, but let's square both sides and then divide both sides by 16 so that we can isolate y. Now, once you isolate y, you're able to find dy from here, because dy basically means, because it's like dy over dt is the derivative. Let's go ahead and do it that way. The derivative of y with respect to t is just going to be, you're going to differentiate this 2 times this, lower the power and divide by the same constant. Of course, they're going to cancel out. That's going to give us 8. But now, if you multiply both sides by dt, I know dy over dt is not a fraction, but it's a fraction. We can kind of write it like this. Beautiful, right? Now, this can be easily solved. It's just another integral. Wait a minute. Yes, it is. Okay, fine. I was like, where does this come from? I just made it a differential equation, right? Okay, great. So now this is what we're going to replace dy with. Let's go back here, and let me copy that here. Dy over square root of 4 root y plus c. Remember, c is an arbitrary constant. And on the right-hand side, we just have the integral of dx, which is going to turn into x plus constant. But let's do that at the end. Now, what am I going to do? We're going to replace dy with t minus c, and the whole thing is going to be square root of t. Because remember, without the radical, this whole thing was called t, right? So we have square root of t. You could also call with the square root, but then you would kind of have to deal with some squares. I think it's going to be, still going to be okay. Maybe even easier, who knows? But this is what we have. And of course, don't forget the dt here. And now this is super duper easy to integrate. Let's go ahead and separate this. This is going to be square root of t minus c over square root of t. And you do know how to integrate square root of t, don't you? If you don't remember that, I can tell you. And now can I just write x plus k, a constant now? Okay, I think it's the right time. Now, when you integrate t to the power 1/2, you're going to get t to the power 3/2 divided by 3/2, which is going to be 2/3, minus, for this one, let's just go ahead and multiply the top and bottom by 2. And that's going to give you, if you integrate this, 1 over 2 root t, it's going to be root t. With the 2c, it's going to be 2c, or not 2c, hopefully you can see what I see, times the square root of t. And of course, that's going to equal x plus k. Now let's go ahead and bring this constant over here as 2/3. And now it's time to go back to what t is. T is the square root of, not the square root of, without square root. Okay, t is equal to, 4 times the square root of y plus c. That's what t is, remember? Now we're going to go ahead and just back substitute 2/3 multiplied by t to the power, which is 4 root y plus c. That's going to be to the power 3/2, which you can turn into a radical if you want, 2c, and then square root of 4 root y plus c. And on the right-hand side, it is x plus k. Of course, solving for y would be super duper hard, complicated, maybe impossible, because it involves solving a cubic equation. Trust me, you don't want to solve that equation, okay? Now, this is a good time to check our results against Wolfram Alpha because it claims to be some type of machine learning or whatever you're going to call it. Let's just a lousy LLM, whatever. And let's see what Wolfram Alpha says about the solution to this problem. Ta-da-da-da. Don't you like that? Okay, beautiful, right? And this brings us to the end of this video. Thanks for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time in another video. Until then, be safe, take care. Don't forget to check out SyberMath Shorts channel and aplusbi. And bye-bye.